Hello, PreCalc. It's 3:17, so you're watching this on St. Patrick's Day, or you're watching it on Saturday or Sunday, sometime before Monday's class. So we've been talking about sequences and working on those for a couple days now, and the last topic that I discussed on video was an arithmetic sequence. And you'll recall an arithmetic sequence is like 7, 11, 15, 19, etc. So, oh, I got a tickle. I think I have to sneeze of all the times. Alright, so 7, 11, 15, 19. So each of those, you can tell you have an arithmetic sequence when each of the terms are the same distance from the next term. So from 7 to 11 is 4, and then 11 to 15, and so on. So that's characteristic of an arithmetic sequence. The common difference is indicated by the letter D, and it equals 4. And we developed a formula. You can always find the nth term of an arithmetic sequence if you take the first term and add n minus 1. So if you're looking for the fifth term, it would be 5 minus 1 times the common difference. And we showed why that was true. So this is the nth term on an arithmetic sequence. So let's say that I am going to take this and come up with a sub n. So a sub n is the generator, and so I want a sub n. A sub 1 is the first term, so I can see here that it's a 7 plus n minus 1. N is going to be in our answer, so I'll leave n minus 1 times the common difference 4. So if I work that out, I get a sub n equals 7 plus 4n minus 4, or 4n plus 3. And where'd that 3 come from? Alright, 4n plus 3. Alright, that 4n plus 3 is the generator for this sequence. So let's see if we could look away from that answer and go back to it. Remember when we were trying to come up with these with no help from that formula, we saw, well, they're each 4 away from each other. So maybe the nth term is 4n, but then we realized that to generate the function, you have to have a 1, a 2, a 3, a 4. So you're going to put this into here and hopefully get this into here, hopefully get that. But notice we're off every time we do that. So we put 1 into this and we get 4. And then we put 2 into this and we get 8. Do you see each time that our function, our sequence, is 3 off? So we put 3 into that, we get 12. So each time we're 3, let's see, we got 1 into this, we got 4, 2 into this, we got 8, 3 into this, we got 12. So we have to add 3 for each, we're off by 3 each time. So you can see we were able to come up with it just by a little bit of trial and error, where this formula was able to come up with it also. Alright, so if you're given an arithmetic sequence and you want the nth term, you can use this formula, leaving n in the problem to come up with it as well. Another type of problem that is famous use of this will be this type. And let's say the fourth term, so we can say a sub n, the fourth term in a sequence, it's an arithmetic sequence, is 20. And the 13th term, so I know n, it's the fourth term in this case. And let's say we also know the 13th term, so a sub 13 is 65. come up with the first 5 terms. All right, so, well, we know the fourth term is 20, and way up here, 13th term is 65. So how can we come up with the rest of the terms knowing this? This is enough information along with this formula to come up with it. So I'm going to feed this information into the formula and see what comes out. This says a sub 4 is 20, so I'm going to put a 20 here for the fourth term. The first term I don't know, I'll call it a sub 1, plus n in this case is right there, 4 minus 1 times the common difference. So that's about all I could get out of that. 20 equals a sub 1 plus 3d. Alright, so then also from this information, I'm going to come up with another formula, feeding it into the formula for the nth term. I get 65 equals a sub 1 plus 13 minus 1 times d. So that is 12d. Alright, so now I have 2 equations and 2 unknowns. So I can, whenever that happens, there's enough information to get both. So I'm going to bring this one underneath of this one and subtract one from the other. So I'm going to minus all of this from here. 20 from 65 is 45. A1 minus A1. 12 minus 3D is 9D. Divide by 9, and I get D equals, the common difference equals 5. So, is that enough to finish this? Well, I know actually it is, because the common difference works both ways. So I can add 5 to this to get this term, and I can subtract 5 to get this term. Subtract 5, subtract 5. So a sub 1 must have been 5. Alright, so that's a famous type of problem that you'll see on placement tests, math tests, pre-calc work. So I wanted to show you how to attack those kind. So I'll end tonight talking about what happens when we take an arithmetic sequence. So we take 3, 6, 9.